AtlantOS. So the machine just told me that the meeting is being recorded. Thanks, machine. And then, yeah, so thank you all for being here in this AtlantOS Ocean Hour. And it's a special Ocean Hour because it is the day of the Ocean Day today. And we are going to talk mainly about ocean carbon. So I have people from all over the Atlantic here today. And I'm just going to show you how we are going to divide our hour today, and I'm going to present all the speakers here with us. Hang on, I'm going to share it now. Okay, here we go. So the idea of having this Ocean Hour every second Tuesday of the month is to inform, the broader community here in our Atlantic Ocean community, science community, but also all the stakeholders on the progress of the use cases on specific themes about the Atlantic. And today we're going to talk about carbon, and to develop and then to promote the community engagement, and also to have feedback from you. It's important for AtlantOS program. And because we want to really create this collective vision of the Atlantic Ocean. And again, it's open to everyone. If you have colleagues that are still, well, what we do, then invite your colleagues now to come and join us to this Ocean Hour. We are going to make it, have it recorded, and it's going to be accessible for after this event. And if you're in the Zoom space, you have a question and answer box. There's the normal chat, but I'll ask you for the specific questions to be sent to this question and answer, because it's easier for us to organize the dynamics when you're having the discussion. And type your comments in the chat here. Everybody's able to see it. And if you want to put your affiliation on your Zoom credit, you can click on the three dots close to your image, and you can change your name or put your university or organization or company. And there's going to be a networking afterwards. And Sandra, the link is WonderMe, is going to be shared. And it's a very nice sort of virtual coffee break. You can move around a room and talk to the people. When you get close to the people, you immediately you're going to see and be able to see and chat to the people there. It's a very fun thing. And the program for today, so today, I'm presenting you now, we're going to have a quick talk by Rick Vaninkoff from NOAA in the US, in the Atlantic Laboratory, about the integrated ocean carbon research. So there's this recently released UNESCO report. It's a summary about ocean carbon knowledge and the vision for carbon research and the carbon observations for the next decade. We're in the decade, the ocean decade. And following, you're gonna have a short talk by Björn Fiedler. He's from GEOMAR in Germany, about the quality enhancement of the tropical carbon fluxes through optimization of a network. And we're going to have an open floor and panel discussion where we have our invitees are Eden Maru from Ghana. We have Vivian Lutz and Carla Berghoff from Argentina, from INIDEP, and Rick and Richard, Rick Vaninkoff is going to participate with us. We have Rodrigo Kerr, he's a professor for chemical oceanography in Rio Grande Federal University in the south of Brazil. And we have Rick Sanders from Norway to discuss with us. And then we're going to follow to our networking space. I hope you all stay with us, and we're going to have a summer break. And our next Ocean Hour is programmed for the 14th of September in 2021. And we're going to talk about a very interesting topic, which is the biogeochemical argo. And in the end, we're going to share again the WonderMe link for you all to join us. And now I give the floor to Rick to start our discussions in the Ocean Hour. Thank you.
Yes, good day, everyone, and greetings from the western side of the Atlantic, where our beaches are covered with sargassum. So it's some of the themes of AtlantOS are our real world themes. So the title of my presentation that Letitia nicely introduced is Why Atlantis Needs Integrated Ocean Carbon Research. And as Letitia mentioned, this is going to be a summary of short summary of the report that we just produced on, under auspices of the Intergovernmental Oceanographic Commission, and I'll basically sort of touch on the themes which I believe are particularly relevant for Atlantis. And the take-home message, or one of the take-home messages, is that we need to recognize that building our big goal in Atlantis of building an integrated all-Atlantic ocean observing and information system requires a vigorous research component. To maintain it, it requires research as well. And then the third bullet, which doesn't show up, which I'd forgotten to put in, I noticed this morning, is actually a really important bullet, is that Atlantis, as an integrated observing system, will be a unique venue in order to perform integrated research and to address these problems. Next slide. So the Integrated Ocean Carbon Research effort is an effort by international science programs and ocean carbon scientists with focus on research needed to address the climate and ocean health implications of the changing ocean carbon cycle in support of the UN decade. And the 5 organizations that are involved in IOCR are SOLAS, CLIVAR, the IOCCP, the Global Carbon Project, and IMBER. And on the right-hand side is the cover of the report. And the report, I think, is a good read, and I would encourage you to download it from the web and peruse it. Next slide. So I think the need for ocean carbon research, and particularly in this day and age, is pretty apparent. We recognize the increased CO2 levels in the atmosphere are leading to warming and climate change. And the evidence is becoming more and more apparent every day, and it's really capturing, and it should capture public attention. Moreover, we've set ambitious goals to mitigate climate change through reduction of atmospheric CO2, and that will have wide-ranging consequences to the ocean, we believe. It's also, we are in a great opportunity that we have a great arsenal of tools and observing systems such as Atlantis to tackle these issues. So I think we are sort of at a nexus where we can really make great progress in addressing these. We have a great framework as called the UN Decade of Sustainable Development in order to implement this, and there is an urgency to do this. This is a quote from the IPCC Special Report on Ocean and Cryosphere, is that climate action cannot wait for research. And then I've sort of dimmed out a little bit, they proceed in parallel. But I think the danger is that we'll forget that we cannot really, climate action does require research. It's maybe it cannot wait, but it has to happen in conjunction. And I like to say, action without understanding leads to disaster. Next slide. So we can go, so basically we are addressing in this presentation the use case in Atlantis. I won't go through all these, they are from the Atlantis page, just mentioning that Letitia and Brad are the coordinators of this particular topic within Atlantis, and the issues map very nicely on IOCR, and it's not completely surprising because Letitia was an active participant in the IOCR effort. Next slide. So the IOCR frames ocean carbon research around 4 foundational questions, which address, what I like to paraphrase the decade slogan of the science we need for the ocean we want to the research we need for the ocean we want. And there are sort of 4 foundational questions which we use to write this report. Will the ocean uptake of anthropogenic carbon dioxide continue as an abiotic process? What's the role of biology? What is the exchange between the other, I call the other interfaces. We put a lot of emphasis on the air-water interface, but there are also 2 other important interfaces, notably the land-ocean and the ocean-ice continuum, which are critical for a landlocked ocean like the Atlantic. And then the final question is, how are humans altering the carbon dioxide cycle? And this question also addresses the possible carbon dioxide removal from the atmosphere. Next slide. So the scientific background is, this is what we basically have done and what we're hoping to do in the future. This is a nice figure out of the report, which was produced by Judith Hawk. And basically shows the partitioning of the emissions into the atmosphere, ocean, and land over since the start of the Industrial Revolution. And then what I've done is use my artistic capabilities to extend this curve, what it's going to look like in the future. And so currently we are in a situation that the ocean and the land take up about half the anthropogenic CO2, the atmosphere, and the remainder remains in the atmosphere. Now, what we're trying to do is, within the US during the COVID pandemic, one of the slogans was flattening the curve. And we recognize with a pandemic how difficult it is to flatten the curve. And it's going to be even more difficult to flatten the curve of the CO2 curve. But essentially what we are at the start of changing our emission scenarios dramatically from an exponential increase to a flattening. And then there is a firm belief that if we want to reach our lofty goals of not exceeding a global temperature of 1.5 degrees, we'll actually have to engage in what is called negative emissions, that we have to increase our sinks. And so the ocean, what the ocean is going to do is somewhat unknown. It could increase as a sink, which we widely believe is probably the case. It could be a factor that it will basically cease to be a sink, or we enhance the uptake and create a a stronger positive sink. Next slide. So I will basically go through each of the four questions rapidly, and then sort of touch upon where I feel that AtlantOS can make a meaningful contribution. And I'll use this cartoon of the global carbon cycle as a template. And so the first question is, will the ocean uptake of anthropogenic CO2 continue as an abiotic process? And this is blowing it up. Currently, the ocean takes up about a quarter of the anthropogenic CO2. Without this, we recognize that the world will be quite a bit warmer. We have a pretty good understanding of the processes that are currently involved, but we still are coping with a fairly large uncertainty. We are building on several decades of sustained ocean observations that have to be continued and have to be highlighted. We are doing a great job on modeling and analysis, and also increasingly using new platforms. What we need to continue this work is integrated research, incorporating modeling and analysis. Next slide. So in AtlantOS, I think this is one of the key issues within AtlantOS. Is the Atlantic Ocean is a circulation-driven ocean, and we also believe that there is increasing evidence that there are changes in this circulation. And the key question for carbon is, what is going to happen to the carbon uptake if this circulation changes? And in particularly, we've seen from some initial work in the past that it seems that the North Atlantic and South Atlantic act a bit as a flip-flop, that when the uptake in the North Atlantic increases, it seems to decrease in the South Atlantic, and possibly vice versa. But that is something that has to require further study. Next slide. The second question is, what's the role of biology in the ocean carbon cycle? And I think it's worth emphasizing that in terms of quantity, the marine biota is a fairly small component, but a really effective component within the global ocean. The total biomass is about 3 petagrams. That's about 1/3 of what we emit every year due to fossil fuel burning. But you also can see from the other arrows that it's a very efficient, both in exporting carbon into the deep ocean and also exchanging between the organic and inorganic pools. We know that without what we call the biological pump, the atmospheric CO2 levels would be 2 times greater. And also we recognize that the CO2 levels, increasing CO2 levels, are having a detrimental effect on a lot of biota, particularly calcifying organisms under the phenomena ocean acidification. What we're doing now is we're building on our current observing systems, which are very focused on physics and biogeochemistry to incorporate biological sampling. And what we need is more integrated research on the living biota, organic carbon, inorganic carbon interactions. Next slide. Within AtlantOS, it is, the big question is, will changes in Atlantic, biological processes affect the ocean carbon cycle? So what are, I think, the basic question, what are the trends in productivity in Atlantic and the effect of carbon uptake? And will the biological carbon sequestration change in a slowing, warming, and melting Atlantic? And the example I show here is a figure from Baranj et al. It's a modeling exercise looking at different RCP scenarios and how the export flux, how much the biological particles are sinking, has changed at 500 meters under these 3 scenarios. And we can see that within the modeling construct, there are huge changes we'd expect, depending on which future scenario we are going to have. Next slide. The third question is, what are the exchanges of carbon between the land-ocean ice continuum and how are they evolving in time? And this is a question, again, it has a high relevance for Atlantis because it really sort of the coastal areas are parts of our EEC and are hugely important for sort of socioeconomic reasons. And the second issue is that Arctic melting has a huge impact on the Atlantic. So we're building on, integrating coastal and open ocean carbon research, and there are several Arctic initiatives. What we need is better links with other disciplines, most notably disciplines which are more closely related to sort of socioeconomic efforts like fisheries, agriculture, and the energy industry. Next slide. So I mentioned Sargassum before, and this is sort of one of the connectivity issues on how the question of Sargassum has caught us, at least on the Western Atlantic, greatly by surprise. That all of a sudden our beaches were covered with Sargassum. We didn't know where it came from. And there are a lot of basic questions on the carbon nutrient cycles, how they're impacting and contributing to the Sargassum explosion. There is some nice remote sensing work done at the University of South Florida, where they are using remote sensing to estimate where, what the Sargassum situation is going to look like. This is a slide for remote sensing estimate of Sargassum, which is really, really dense. Last month in northern Brazil, southern Caribbean area. And we expect that a lot of this is going to end up in the central Caribbean and in the East Coast. Next slide. And the last question is, how are humans altering the ocean carbon cycle? And I'll focus here on the possible purposeful carbon dioxide removal. And I would sort of make some cautionary remark here is that I used a slogan earlier on, climate action cannot wait for research. They must proceed in parallel. I think for carbon dioxide removal, we must wait for research. It's apparent. It's a socioeconomic, imperative that we look at this. But our knowledge of perturbing the carbon cycle meaningful is incomplete, and it will require significant more research and understanding of the natural carbon cycle before we want to do meaningful changes on increasing sequestration. But there are many different approaches. There is a lot of commercial interest in a lot of these approaches, and this is in part because carbon dioxide removal has a cost associated with it and possible profit if it becomes a viable mechanism. So, we basically have to build on increased understanding observations of the natural carbon system through organizations like AtlantOS. And then basically what we need is basically, basic research, innovative ideas, process studying and modeling. Next slide. So I think to sort of emphasize the marine carbon dioxide removal, we believe that a lot of this will occur within countries' EEZs, so they can claim carbon credits. And on the left-hand side, you really can see the EEZs very clearly, but this is, the Atlantic Basin and the surrounding continents. And then the right-hand side is a cartoon of the exclusive economic zones where supposedly countries could engage in carbon dioxide removal, because currently within the open ocean, the London Protocol, we believe, prevents a large-scale efforts for carbon. So it's probably going to happen EEZs. But you see that there's a huge amount of EEZs within the Atlantic Ocean that could be areas where these techniques are going to be implemented. And I think this is next slide is the final one. So I would basically leave you with that the critical goals of AtlantOS will not be reached without an emphasis on integrated ocean carbon research. And thank you.
Thanks a lot, Rick, for it's good to see that you adapted the IOC report to our AtlantOS goals, and yes, I mean this is a hot topic on about the marine CGRs and the carbon credits, and we saw, I don't know how many different countries we count on the Atlantic's EEZs, I mean north and south, and then with that. I will ask Bjorn to now talk to us and talk about this enhancement on the carbon observations in the tropical Atlantic. Thank you. Your mic is muted, sorry.
Yes, of course it was. Okay, yeah, so I hope you can see my slides now. Yeah, thanks a lot for giving me the opportunity to present the work we plan to carry out in the tropical Atlantic this fall to optimize, to carry out a demonstrator mission about optimizing the network capabilities for carbon observations in the tropical Atlantic, also by using new technologies, what Rick has just mentioned. So before I say something about the mission itself, let me say a few words about in which project this work is being embedded. This mission is being part of the EU project EuroSea, which, so to say, stepped a little bit into the huge footprint of AtlantOS project. And the project itself is on improving and integrating the European ocean observing and forecasting systems for the sustainable use of the Atlantic Ocean. And it will strengthen the different observational systems, also work on increasing the technical readiness levels of different systems, and also contribute to the coordination of different observing networks. And in the end, the ultimate goal is to work towards an integrated observing system. So many similarities with the AtlantOS program. And on the sketch here, you can see the work package. Our work is included is the work package 7, which is a demonstrator work package, and is surrounded by different by other work packages within EuroSea. Yeah, so the the work we want to carry out as part of the work package 7, which is the Ocean Climate Indicators work package, consists of 3 different tasks. And we have one task, which is evaluating the economic value of deep convection regions in the North Atlantic and also in the Mediterranean Sea. And yeah, so for example, in the context of global stock trade as part of the COP21 Paris Agreement, we have our task, which is focused on the tropical Atlantic carbon fluxes by optimizing the observing systems in the region to upscale spatial temporal coverage of carbon fluxes. And then also there's another task which will generate observable and user-relevant marine indicators for a reliable uncertainty of the Atlantic Ocean and Mediterranean Sea, and to demonstrate the end-to-end connection from climate and seasonal forecast products to stakeholders. And so this is a value chain of this work package here. And we will work in the tropical Atlantic this fall by using different, combining different observational systems with each other. So I'm going to show you what we want to do. So as you know, you can see here on this map, you can see the tropical Atlantic observing system, the TEOS, which consists mainly of the well-maintained sustained observations through the PIRATA program, where different nations around the Atlantic are engaged. And what you can see here, the shaded areas is the density of Argo floats in the region. And if you have a closer look, it's hard to see here, but regarding carbon observations, CO2 here, there are only very few places where carbon is being observed on the long term. So there are a few moorings which are being maintained. Some of them have gaps in their data. And so the tropical Atlantic region is really a region that is known to have only very few carbon observations. Of course, we have volunteering observing ships or soup lines, I have to say, which crossing that region. But in general, there's a very poor coverage. If you look at the biogeochemical Argo program, which is emerging, you see that there are only, I think now we have 5 floats with pH sensors in the region, which we have actually deployed. I will say a little bit more about that in a moment. And in other regions, of course, colleagues from the US apparently have deployed quite a large number of floats currently, but there's only there's almost no carbon observations in the region. So, and we follow in our task, we are working on optimizing this network by using modern platforms to connect the different existing carbon observations with each other, and also further extend the observations. So we will deploy biogeochemical, or we have already deployed biogeochemical Argo floats with pH sensors, equipped together with colleagues from Brazil, Pirata mooring with a CO2 sensor. And we will launch a sail drone mission this fall to, and this I can show on the next slide, where we, here's shown again, we want to equip Pirata mooring together with our Brazilian colleagues with a CO2 sensor. We have floats deployed already, and colleagues from France, as part of the French Pirata program, have already deployed CO2 sensors. And the aim is now to launch a sail drone, an autonomous surface vehicle from the US, sailing all the way into the tropical Atlantic region, doing a circumnavigation, and having crossover with the different sites where carbon dioxide is being measured. And also then we'll target the floats which are in the region and aim to cross-reference these different observations with each other. Try to improve the quality of the carbon measurements by this, because it's a high quality CO2 sensor, which is also being validated soon by the ICOS intercomparison, which is will start in 2 weeks' time, I think. Through that, we will also, through these extended observations, we will also apply a neural network approach through the Kenyan approach, and thereby upscale the coverage for the carbon fluxes in the region and feed this into the value chain of the EuroSea project. So this mission will start soon, and it's really great to have the opportunity to talk to so many stakeholders here today. And we are really open for collaborations. And if you want to get on board and contribute, give feedback, advice, etc., please get in touch with us. And then we want to get as many stakeholders involved as possible into this mission. Thanks a lot, and sorry for being a little bit over time.
Thank you, Bjorn, for presenting the activities planned for the tropical Atlantic. And well, I guess now we're sorry. I mean, we're still waiting for one of our panelists, which is Dr. Ede Mau from Ghana. Well, we're trying to get in touch with her, but in the meanwhile, I'd like also to hear from our panelists as well. Your ideas about the carbon cycle and all this carbon uptake and use, I mean, the uses that the ocean carbon research can have in the Atlantic. And well, I'll start talking to maybe Carla and Vivian from Argentina, if you want to, if you have, I guess you have something to share on the screen with us. And yeah, and I mean, leave it to you.
Okay. Hello. So I will present some short slides. So do you see it well? Please let me know. Okay. So I'm gonna run through short slides to tell about the status of the carbon observing system in the Argentina Atlantic sector, and to get an idea of what you asked, Letty. So it's been like 20 years almost since Argentina started to monitor and to make a big effort about studying the carbon system, and this was a huge project 15 years ago, and that covers all of our economical sea. But after that, we didn't have that huge projects. We are participating in international and national initiatives, mainly focused on the central North Argentinian part of our sea. And we are running, for example, coastal time series, recently incorporate carbon system studies, but the only big effort is that we are having now is the SAMOC, that of course a lot of countries participate, and a few recent, let's say, not opportunistic, but not directed studies in the Patagonian Sea. So how can we cope this, and how can we make our Argentinian effort to work and to include the coastal areas? So apart from EPEA is an ecological time series that it's been running since 2000, and since 2015 we started to take in situ measurements of pH and total alkalinity. But how can we make a bigger effort in Argentina? So nowadays, ROMA, which is a new observation system that is starting, will have different coastal observatories all around the Argentine Sea. And and as part of the Pampa Azul project, it's our umbrella, but with the help of different international and national initiatives, we are hoping to get a new idea and recent idea of what's happening in our sea. Our sea is really productive. Our sea is really variable. Previous studies show that we are a strong sink area, but we really don't know what's happening now, and the variability of seasonal, daily, or even interannual variability of our sea. So, and I think these coastal observatories, with most of them will include some carbon system studies, will improve the knowledge. And also there's other initiatives like Remarco in the Buenos Aires area that will improve the understanding of what's going on. And something interesting, as EPEA or Remarco or other time series that they're just beginning, they will have a huge important biological component. not only physical, but also biological component. And I think that will be key, and soon we will have nice results. But also we acknowledge that we have a huge gap in monitoring in our sea, the PCO2. So since 2017, we are lucky to have a really nice PCO2 underway system. And we are taking measurements while the RV Angelescu, which is a fisheries research cruise, sail around our seas. And I think it's a nice contribution. We already just, the first contribution just started, and we send already the data to SOCAS. So I think these initiatives are just starting and are refurbishing for previous initiatives, and hopefully we can cover all the sea in our region. Thank you.
Thank you, Carla. Thank you for presenting the initiatives. And I'd like to, now we move, gonna make back and forth to the eastern side of the Atlantic. I'm very happy to have Dr. Eden Mahou. I hope I'm pronouncing your name well, Eden. And we'd like to hear about her, about your experiences, and if you want to have comments on this topic, on the Atlantic Ocean carbon cycle. If you're ready to join us to step in. Eden, can you hear us? Are you listening to us? If you can type on the chat, we can just, then we can, let's stay on the western South Atlantic then, and move to Rodrigo, and then we go back to, we go east soonish. And Rodrigo, if you want to present. Hi, Eden. I can see you now. And I'll ask Rodrigo, and I'll start sharing the screen to show Rodrigo's.
Hello.
Hi, Eden. Hi. Well, there was some so
I think we will shut down Eden's camera, since it seems to take too much bandwidth from her.
Yeah, can we if you don't mind, we start with let's hear Rodrigo, and then we move to Eden, and see if the connection, if we close the camera, or we just do our best. And Rodrigo, this is the floor is yours. So just tell me, and I'll
okay. And hello, everybody. First of all, thank you for the invitation from the AtlantOS program to be here with all of you today. And I will try to be very brief. I have prepared 4 slides on to show some recent works that were done in the South Atlantic Ocean. So I'm Rodrigo Kerr. I'm a professor of oceanography in the Federal University of Rio Grande in Brazil. I'm also, together with Leticia, co-leading the Brazilian Ocean Acidification Network, and also coordinate the carbon chain locally. And next, please, Leticia. Hope that my voice is not robotic, because my connection is not so good. So I really like this slide that I have prepared before for the LAOCA meeting. Carla and probably know that we prepared this slide together, because it is we have an overview of what we already know about CO2 carbonate system, and also ocean acidification in the Western South Atlantic Ocean. Now, we all know that the Western South Atlantic Ocean is an undersampled region, and this is especially true for the biogeochemical essential ocean variables, as also Bjorn showed before for the tropical Atlantic. However, we know something about how the biogeochemical provides, how each of the biogeochemical provides behavior as CO2 source or CO2 sink zones. However, we don't know about the better about the CO2 system parameters distribution, how is the spatial temperature variability, how is the drivers of the CO2 in our role area. And of course, because of this, our level of knowledge regarding the ocean acidification status in this area is very low for the majority of the areas. One other thing that I would like to highlight in this slide is related to the central waters of the South Atlantic. The central waters in the South Atlantic are acidified faster. So when we compare the rates of the acidification with the surface or the intermediate, so the layers just above or below the central water. And also the main central water mass that circulates around the western South Atlantic Ocean is formed in the Brazil-Malvinas confluence zone, near the boundary between Argentina, Uruguay, and the south of Brazil. And this water mass recirculated by the Brazilian current gyre, and suffer with several physical processes like eventual or permanent upwelling in some specific areas of the Brazil, or intrusions on the shelf. And so we have a really impact on our ecosystems. We have a vast of marine ecosystems, like from deep corals in the tropical to rhodolites or mangroves in more south. Next, please, Leticia. I bring here some recent results from the work of Dr. Rossell and Dr. Carvalho. The first two figures show, and I really synthesized the message of those works. The first one, published in Progress in Oceanography, show the whole of the agulhas heads on carbon uptake. And Dr. Rossell shows that analyzing 6 of those structures show that the area under the influence of those structures in the South Atlantic that can live for more than a year and can cross the Atlantic and also reach the Brazilian ecosystems are areas of intensifying carbon uptake. Also, she showed in another work that during the translation of these ads around the South Atlantic, from the eastern to the western boundaries, and they are transported more contents of anthropogenic carbon. So are probably one of the processes that can explain why we have the central water masses being acidified faster than others, for example. In addition, the study of Carvalho, published also in Progress in Oceanography, related how is the CO2 flux with the main phytoplankton groups in both the western, the eastern, and the central gyre of the South Atlantic Ocean. The work showed that the CO2 flux vary from small periods of alt gases, mainly in the western boundary current domain, to strong uptake in the eastern boundary domain. So also, even we know that temperature, the physical parameters are ruling the CO2 flux in this area. Carvalho showed that we have a strengthening of the CO2 uptake in the South Atlantic through the phytoplankton, the main phytoplankton groups present. So in the eastern boundary region, this is mainly dominated by diatoms and the aptophytes that are large phytoplankton organisms than the one that we find in the eastern, in the western boundary margin the Brazilian coast. Also, we have a gradient of the transition of those phytoplankton groups from small cells like cyanobacteria to large cells from diatoms and epitophytes in the south of Brazil. Next, please, Leticia. So we are provoked with two questions, and I will be very brief now in this two slides because Ricky tell some points that I really agree with. And how can we measure optimum design, observation, monitoring, and evaluation systems in the continuum from the coast and the open ocean? First of all, we need to think that we have all the human resources available, that they are trained, that they are efficacious at some institution, and they are working on marine biogeochemical issues or on other ocean-related sorry, I forgot, but also with human resources, we need to have the infrastructure to monitor and to observe, like ships and buoys, and have to have the financial support to start to work and understand the ocean continuum. We do not forget that when we think the ocean continuum, we're talking about different spatial and temporal scale. So the process that we are talking about are different from we have on the coastal and shelf and we have on the deep ocean. Also, the time of the time of evolving of the process is also different. So scientifically, to start to answer this question, we should focus on how better we know about the meso and submeso scales on ocean carbon uptake in the ocean. So we should focus on that type of study to better understand. So it's the relation between the chemical, the physical, and the biological issues, but in a scales, in small scales. So the last one, please, Leticia. To finalize my message here, I will not prolong so that, but how can we monitor the long-term impacts and efficiency at coastal open scale with regards to carbon geoengineering? So I bring back, Carla also knows this slide. This is the final remarks of one meeting that we have in Laoca. So when we think with monitor, we need to start monitor for many of our countries that's boundary the South Atlantic Ocean, to know what? To know the seasonal variability, to know the interannual chance, and also to know a little bit about the long term and how the regions evolve in different time scale than the longer time periods. So regarding the long-term impacts, first we need to know the observation and how disease evolve, but probably we need to give more efforts regarding the modeling of biogeochemical to improve not only the understanding of ocean acidification too and the carbon flux, but also the connection between the biology, economy, and socioeconomic things. The final bullet just to talk about how we can achieve this is when we don't have the date set available, but we also have some of the date sets, and we can have our maximum from those date sets. And so in our group now, we are working on reconstruction and model, for example, the marine carbon parameters to understand also the variability, interannual variability, the spatial distribution of the parameters, and also, when possible, to describe something related with long-term chance. So that's it. Thanks for the time.
Thanks a lot, Rodrigo. And would you now, Edem, can you join us now?
So I've asked her if she would like to speak, because I had to mute her because we've heard the car noises again. So Edem, please accept the allowance, or that you can speak.
Okay, so I should, I mean, I didn't get it. So I should unmute her? Sorry, Sandra. Oh, there we are. Yeah, please, Eden.
Okay, hello, good afternoon.
Hi.
I'm sorry, I'm driving, so I cannot give any presentation, but yes, I'm following the seminar. And then here in the Gulf of Guinea, in the Eastern Atlantic, to be specific, we are just starting a program or a project on ocean acidification monitoring in the Gulf of Guinea, with support from POCO and the Ocean Foundation. So what we have started doing is that we realized that the capacity to do ocean acidification observation is lacking in this region. So what we've started doing is to first of all train scientists in the through support from the partnership from the observation of the global ocean. And then we also have support from the Ocean Foundation to, after the training, equip these countries. So far we are working with about 6 countries. We have Ghana, we have Nigeria, we have Benin, we have Cote d'Ivoire, we have Liberia, and then we also have Congo. So basically, these are the countries that we are going
Edem, we cannot hear you anymore.
Oh, guess we lost the connection.
Yeah, perhaps we move on.
Mm. And Richard, and Vivian, I mean, we'd like to hear from you, and then we go back to Edem when the connection is back. Thank you.
So who would you like to go first, Lucia?
I mean, I don't know, then Vivian, if you want to say a couple of words, ladies first, let's do it like this, and then we move to Richard.
Okay, thank you very much for the invitation, first of all. And maybe my comment, because I'm not an expert in the carbonate system, though I'm in charge of the program of plankton dynamics in Argentina, where Carla is working. And of course, this subject was one of main interest when we decided how to expand the program, and when we decided to include this instrument to monitor PCO2 in the new research vessel that our institute acquired a few years ago. And it was a big challenge, and of course we acquired Carla at the same time, and recently a new junior researcher. But my comment would be more, apart from the challenges on the observations themselves that were very well presented here, is the challenge to continue these monitorings. And we could see in the maps that apart from the variables, it becomes clear that the amount of data is correlated with the resources of the big institutes behind them. So I think in the southern part of South America, at least in Argentina, we're just starting, but we need to increase these efforts. And for that, I think that, of course, we need more resources, as also Rodrigo pointed out very well. And how to do that? And I think, first of all, we have to do an inside job inside our own countries to increase the concern of our own decision takers or politicians. And we also need to increase these international collaborations, because these are very important. We have an excellent example when Carla got this peer-to-peer grant, and the help of Denise Pierrot was really very, very important to have these first steps in a secure way, because these type of measurements, as you know, they are very difficult, they are very sophisticated, and they have to be done in a proper way. So I think that my concern in this forum is how to increase in a good way the observations, and how to attract the attention of our countries in this regard. Thank you.
Thank you, Vivian. And Richard? And we'll start slowly moving to the end, and then we'll move to the coffee.
Okay. Well, thank you very much. I haven't prepared any slides, so I'll just say a few things and try and keep it brief. So I was really delighted to be asked to join this call, because quite apart from my sort of, what I do for a living, this is a subject that's very close to my heart. The scale of the anthropogenic perturbation on the ocean carbon cycle, is vast. We have not only does the ocean take up a large amount of carbon, but the sign of the interaction that the ocean and the atmosphere have has actually reversed as a consequence of our actions. In the past, the ocean used to be a minor source of carbon to the atmosphere, but now it's a sink. And I think that change in direction of the flux is really indicative of the huge impact that we as humans have had on the way that carbon and the ocean interact with the atmosphere and with people. So that flux is reversed. And that flux is not stable over time. It's accelerated. The instrumental record is about 40 years long, and there have been big changes within it. As we move towards net zero, it's really very, very unclear what's going to happen. So we've just gone through about 419 ppm I saw. It's going up at about 2.5 ppm per year. That leaves us about 10 or so years. What the ocean does over that 10 or so years is really, really crucial to our pathway to net zero. And in order to understand what the ocean's doing, we need data. And so we need data from across the globe. But I would advocate that we need data, particularly in the Atlantic basin, because as many of us work on, the Atlantic basin takes up disproportionately large amounts of carbon at the sea surface for a whole variety of reasons, mainly related to ocean circulation. So we need lots of data in order to understand the role of the ocean in taking up carbon dioxide, and of course the ocean acidification that goes with that, and the consequences for organisms. So our perspective is that this effort that's being catalyzed here could not be more important. We really need joined up, well-coordinated observing systems that link together strongly and can give us good data in real time, so that we can alter our climate mitigation policies, the emissions policies, if we need to. Frequently we say that forewarned is forearmed. So, if we have information, then we can make sensible evidence-based decisions, whereas if we don't, then we're just kind of operating in a vacuum. So the value chain of observing systems is really, really important here, ranging from people making new technology through to people deploying it, databasing, calculating fluxes, and communicating results to policymakers. And at the moment, some of those steps in that value chain aren't very strong. So anything that AtlantOS can do collectively to kind of strengthen that observing system via the sorts of initiatives we've heard about here is really, really important. So I'm really looking forward to the next phase of the discussion, and thank you for your time.
Thank you, Richard. Yeah, I mean, this is very important. I mean, to know, I mean, how the ocean is going to be in a 10 years times, by the end of the ocean decade, for instance. And we got a question here in our question and answer, and it's from Sarah Nickford, and she's asking, well, she's saying the following: a common goal among many speakers is to optimize measurements. And she asks if are models being used to help reveal the spatial and temporal distribution of measurements to optimize the networks? And more generally, how do we define the goals we are optimizing for, and how will we know if and when we have succeeded? I mean, this is a bigger questions, but I mean, I would maybe for the areas of the Atlantic where we still making efforts to optimize measurements. I mean, if any of you want a question, and after that, I guess in the end, we have closing remarks, and then we can move to the chat and the we move link Sandra just shared with us.
Hi, Leticia. I was online, but I think I went off. So I actually didn't know the point that I went off. Regarding what we are doing in the Gulf of Guinea, in the Eastern Atlantic.
Yes, yes, go ahead. Mm-hmm.
Yes, so I said that this area or this region of the ocean is actually understudied as far as carbon uptake is concerned. So recently we started a new project called the Biota project, building capacity in ocean acidification monitoring in the Gulf of Guinea. And this is in partnership with the POGO, Partnership for Observation of the Oceans, and the Ocean Foundation. So what the project is doing is we are a network of five countries or 6 countries. We're still trying to get one more country on board that border the Gulf of Guinea. And the project is doing 2 things. We're trying to build capacity in ocean acidification observation. So i.e. Looking at the physical chemistry, and then also looking at biological monitoring as well. And the training sections will start this August. And we are fortunate to have the Oceans Foundation supporting this project with equipment. So once we are through with the training sessions, each of these countries will be given equipment to start ocean acidification observation. So this could be biological or just looking at the chemistry. And we are also doing this in partnership with our governments. So basically, that is what we have started. I know there are some individuals who probably are working or are collecting data on pH and other stuff, but this is so far the biggest project in the region that is about to commence as far as carbon uptake in the Atlantic or in the Eastern Atlantic is concerned. So that is the contribution that I have to make at this point. Thank you.
Thanks a lot, Idem. Thanks a lot. It's good to have you back here. And I saw that. Thanks, Richard. You answered the question, and then there's the observer system simulation experiments. And Sarah, I would also, I mean, if I may, Rodrigo and Carla, ocean modeling is still how do you say, is one of a sort of a bottleneck here in South America, for instance. So we do need more. We have modelers, but we have lots of people dealing more with operational oceanography. So things related to weather, much more than biogeochemistry. So to have this integrated models where we have the physics, but you also have the carbon cycle integrated. So we see we are in different stages inside the Atlantic. It's one ocean, but we have different realities. And then I guess that explains all. And now I invite you to go to the Wonder Me. So the links in the chat. And when you move to Wonder Me, you're going to become bubbles like this, and you can move your bubble around and talk to the people you want, because then we'll be able to see everybody in the everybody who's in the room. And as soon as you get there, you can talk to each other. Sandra, do I have to say something else before? And also thanks everybody for for your time and for being here, and everybody who was watching us. Do you want to say something else, or any doubt or anything?
I think it's a great start for this more informal conversation and networking we can do via WonderMe. Just make sure that you use either Chrome or Edge or Firefox for this, so that these are the browsers that work best for WonderMe. And yeah, looking forward to talking to you soon. Thanks a lot.
Yeah, and then the speakers, everybody, please, if you can move to WonderMe, it's gonna be great to have you all there. Thanks very much.
Longer here, so if anyone has issues, just raise your hand and we figure it out.
Yeah. Thank you very much.